Newton's second law of motion states that the resultant force acting upon an object is equal to the product of the mass and acceleration of the object. So resultant force can be represented by F net, okay, is equal to the product of the mass, that is M, okay, and acceleration, so M times A. Right, therefore you have this equation over here, F net is equals to MA. The direction of the net force is always the same as that of the object's acceleration. So for example, if an object experiences a net force towards the right-hand side, then I expect the acceleration to be also pointing towards the right-hand side. Okay, so the force vector is in the same direction as the acceleration vector. But if you look at the SI units of force, mass, and acceleration, SI unit of force is Newton, SI unit of mass is kg, and SI unit of acceleration is meters per second square, right? Therefore, we can define what is 1 Newton. Okay, 1 Newton is defined as the resultant force that produces an acceleration of 1 meter per second square, okay, when the mass is 1 kg. So you look back at this equation again, okay, when you have a 1 Newton net force, okay, acting on a 1 kg mass, then it should give you a 1 meter per second square acceleration. Okay, so 1 Newton equals to 1 kg times 1 meters per second square. Now, when you're solving questions, please take note, okay, always check that you have converted M and A into their respective base SI units. Okay, so that when you are doing the calculation, the net force is in Newton. So for example, okay, in this case where mass is 350 grams, instead of substituting 350 directly, you have to convert 350 grams into 0.35 kg, okay, before you can multiply it with acceleration, okay, which is already in meters per second square. So F net equals to MA, you have 0.35 kg times 10, 3.5 newtons. If an object is undergoing free fall, okay, then the only force acting on the object will be its weight. And the object is then said to be accelerating, okay, at the acceleration due to gravity G. So over here, this is the free body diagram of the object, okay, that is only experiencing its own weight. It will be accelerating at acceleration due to gravity G. So applying Newton's second law, F net on the object is weight, okay, and its acceleration is G. So we can represent it as weight is equals to mass times G. Example 6.5.1. Given that M is 120 grams and A is 0.60 meters per second square, calculate F net. Okay, so since you have something in terms of M, something in terms of A, and then calculate F net, what should come to your mind will be applying Newton's second law, F net equals to MA. But before you do the substitution, check. Okay, check the units. The mass and acceleration in the correct SI unit. Okay, if not, then do the conversion. So in this case, we have 120 gram. So we need to do a conversion, okay, from grams to kg. That will be 0.120 kg. Acceleration is already in meters per second square. That's the correct SI unit, so no further conversion required. Okay, so this is 0.120 kg multiplied by 0.60 meters per second square, and therefore you get 0.072 newtons. B. Given F net is 4.0 newtons and the mass is 2.5 kg, calculate A. So in terms of equation, again, we're applying F net equals to MA. Okay, this time around A is the unknown, make it the subject. So A is F net over the mass. Okay, check, are you given the information in SI units? Okay, so force is in newtons, that is correct. Okay, mass is in kg, that is correct too. Okay, so no further conversion required. Just substitute 4.0 over 2.5. Okay, so you get 1.6 meters per second squared. Part C. Okay, given F net is 0.32 newtons and A is 9.8 meters per second squared, calculate M. So F net equals to MA. This round, M is the unknown, make M the subject. F net over A. Again, F net is in newtons, A is in meters per second square. No further conversion required. So 0.32 over 9.8. We get 0.033 kg.